Hello student, let's try to understand the crystal field theory student. What are the point of the crystal field theory is there? It assumes ligand and CMA interaction to be purely ionic. It doesn't explain the covalent nature of the bond. So that is the bond between the CMA and ligands are purely ionic. It assumes ligand and CMA to be the point charge, that is dipole. So both are the central metal atom and ligands are point charge. CFT explains splitting of only d orbitals and do not comments on the sp orbitals. So only it tells about the splitting of d orbital or the involvement of the d orbital in the coordination compound. Next one, CFT always gives exact value of the magnetic moment. Okay, so exact value of magnetic moment cannot be given by the uh, valence bond theory, but it gives the exact value. It doesn't give information about the hybridization. Okay, unlike the valence bond theory. So metal ligand bonds are purely ionic, that is the first point. Metal ligands are considered to be point charge. The difference in energy between two sets are called the crystal field splitting energy or CFSE for the octahedral delta naught and delta O, and for tetrahedral delta T. Metals d orbital is split into two sets when ligands approaches, that is T2G and EG sets. So T2G and EG sets are there. In octahedral, ligands approaches along the axis. In tetrahedrals, ligands approaches between the axes. Stronger the ligands, greater is the splitting energy. These are the point student. So T2G sets are dxy dy z dzx, dx square minus y square dz square are the EG set. Crystal field octahedral complex. So ligands are approaching from the axis student. So whatever the orbitals in the way phase repulsion student, FACE phase repulsion, so they go up student. So which orbitals are along the axis, that is the dx square minus y square, it is having high energy. How much high energy student? Plus 3 by 5. How much energy less student? Minus 2 by 5. So this is either you can write plus 0.6 O naught and minus 0.6 O naught. Total, if you are talking about the, this is what the concept. Now the next one is student, in the tetrahedral complexes ligand approaches between the axis, so the T2G orbital phase repulsion and energy get increased. This is so plus 2 by 5 and minus 3 by 5. Calculation of the CFSE for the octahedral complexes, that we will be able to do that case student. How you can calculate the CFSE student for octahedral? So delta naught minus 0.4 delta naught into x plus 0.6 delta naught into y. So this is what, this is T2GEG. This is the, for 3 electron energy is minus 1.2 delta naught. Thank you very much for watching students.